Hello again, 7th graders. So today you're going to be working on the gizmo for natural selection. And this video is going to be focused more on specifically going through the entire assignment and giving you a little bit of help if you would like that. The other video that's embedded in the assignment was just more of an introduction to the assignment and this process of natural selection. So when you're starting out on this gizmo, the first part you've got to work on is just the prior knowledge questions. And these are ones that you should do before using the gizmo, as you can see highlighted in the red. So there's a moth called the peppered moth. It is really common, or was really common in Europe, Asia, and North America. It's commonly found in two different forms, or they call those forms morphs, a dark morph and a light speckled morph. These moths are frequently eaten by birds, so birds would be a predator of them. So the first question asks you, which morph do you think would be easier to see on a dark tree trunk? Do you think it would be the light colored or the dark colored morph? And you just need to write in your guess here on the line. The second question, which morph do you think would be easier to see on a light colored tree trunk? And you would write in your guess. Would it be the dark morph or the light speckled morph? So that's the prior knowledge questions. Then we're going to move into the gizmos warm-up. And usually this is just a chance for you to practice using some of the tools on the gizmo to help you get started. So this gizmo is going to allow you to play the role of birds feeding on peppered moths. The initial population of 40 moths is scattered over 20 tree trunks. Click on the moths to capture them. Then you're going to click next tree, or if you are using a computer, you can use the space bar to advance to the next tree. So I'm going to check that light trees is selected, and then I'll click play to start and hunt moths for 1 year. So I'm going to slide over to the gizmo, and the play button is right here. You can see the gray shadow from my mouse. We're going to click on that, and you're going to capture as many moths as you can. Don't see any. There's one. Okay, so that shows you 1 year being done. Now, if you look on the gizmo, at this chart over here, it shows you that I captured 4 moths that were dark colored, and I caught 0 that were light colored. You do not need to write this information down in a chart. This is the only time you're going to need to write it down. So if I slide back over to the worksheet here, how many dark moths did you capture? How many light moths did you capture? So I would write in 4 and 0. Now maybe your numbers will be different than that. Next it says camouflage is coloring or patterns that help an organism to blend in their environment. It asks you which type of moth is better camouflaged on light bark. Write in your guess. That's all you need to do. Question 2, if a forest contained mostly light colored trees, which type of moth would you expect to be the most common? Write in your best guess based on what you already know about camouflage. Now we're going to move on to activity A, which is going to be on the second page. So to get this ready, we need to click reset. We're going to check that the light trees tab is selected. So if you look on my gizmo over here, light trees is selected. I need to click reset.
And we're ready to go. So the introduction says, before the 19th century in England, the air was very clean. The bark on trees was usually light and colored. Abundant lichens. Now lichens are when an algae and a fungus are growing together, they have a symbiotic relationship. Abundant lichens growing on tree trunks also lightened their appearance. So next, we've got a question we're going to be investigating. How does the color of a peppered moth affect survival? And you need to predict over time what will happen to the population of light and dark moths on light trees. Again, this is your prediction. There isn't necessarily a right or wrong answer. Now, using the simulation, you're going to be doing an experiment. So you're going to click on play and hunt the peppered moths on the light tree trunks for 5 years. In each year, you're trying to catch as many moths as you can. You can use the spacebar to move to the next tree if you have a computer that you're using. After 5 years, we're going to do some recording of some data. So I'm going to pause the video and go through and do this, and then we'll look at the data. So I have now completed the year 5 in our simulation of the birds hunting for moths. And now if you look at our packet that we're going to be filling in, now we have just finished step 2 here where I've got the gray dot. It says after 5 years, you're going to select the table tab and record the percentages of each moth type. So if you look over on the gizmo, where I've got the gray dot here, there's a tab that says table. So you're going to tap on that, and it will give you this chart. And this is the one we're going to be looking at, the first one. This chart shows you the percentages of moths that were dark colored and the percentage that were light colored over the course of the 5 years. So when we started at year 0, we had 50% of each type of moth. So what you need to do is copy these percentages onto the chart on the worksheet. And then you can use that information to help you answer these questions. Question 3 asks you, what do your results show? And so if I look at my results, I started with 50% light color and dark colored, and after 3 years, I had 0% dark moths in my population and 100% light colored moths. So look at your data and see what it shows you. Which type of moth do you think was more common before the 19th century when most trees were light in color? So when the trees were light colored, like we have currently over in the gizmo, which type of moth do you think was more common? The light colored moths or the dark colored moths? Question 5 asks, what strategies did you use to hunt for moths? So when you were hunting for moths in the gizmo, what were you looking for? Were you just looking for the dark colored shapes? Were you looking for specific parts of the moth? Was your strategy to just go to the next tree if you didn't see anything right away? Like, what were you thinking about as you were hunting for moths in the simulation? Next, we're going to go on to part B. In part B, we need to do as the instructions tell us. We need to click reset. So I will do that on my screen. And we're going to change it to dark trees. So if you look where I've got the gray mouse circle hovering here, dark trees, we're going to select that. It's going to change the background. Then in our introduction here, it tells us that in the 19th century was the Industrial Revolution in England. And with most of the new industries using coal for energy, the air was polluted with black soot. In forests near the factories, the soot coated the trees and killed the lichens. Remember in the first page, it told us that lichens were when algae and fungus lives together, and they help to make the trees to have a lighter colored speckled pattern on their bark. As a result of this, the trees became darker. So the question we're going to be looking at is, how did air pollution affect moth populations? So before we start, we want to predict over time what will happen to the populations of light and dark moths on the dark colored trees. This is a prediction, so just write down your best guess what you think is going to happen for number 1. For number 2, we're going to be doing the same experiment that we did on the first page, where you are going to be a bird trying to capture as many moths as you can. However, this time, we're going to have a dark colored tree bark as our background. So what you need to do is you are going to do the same experiment. You're going to collect data for 5 years. Then you will write your data down on the chart and use that data to answer these 2 questions that go with them. So once you have collected your data, you're going to copy the percentages off your tables chart from the gizmo and then answer these questions. So question 3 asks, what do your results show? So looking at those, did it show a change in the moth population? Were there more dark moths this time? Did it continue to be a population that was mostly light-colored moths? What does your data show you? Number 4, which type of moth do you think was more common during the 19th century and why? So the 19th century, just a reminder, like they said in the introduction, that's when the Industrial Revolution occurred. And that made a lot of the trees appear to be black or very dark in color as far as the color of their bark goes. So which type of moth do you think was going to be more common? The light-colored moth or the dark-colored moth? And why do you think that is? Think about camouflage. Think about how you were able to capture the moths. Think about what your data shows you. Which ones were more common? On the last page, we've got 3 more questions. The first one starts by giving you the definition of natural selection. It says natural selection is the process by which favorable traits tend to increase in frequency over time. So that would mean it's the process where the traits that are helpful or benefit the living thing, the process where those become more frequent over time or become more common. How did this experiment illustrate natural selection? So how did this experiment show you how the favorable traits became more frequent? So you're going to think about, how did what we did with the moths, where you were pretending to be a bird, how did that show you the good traits, the ones that help them camouflage? How did it show that becoming more common in the population of moths? Question number 6 says, did the changes you observed in the moth population result from individual moths changing colors? So did the moths actually change colors? Did one moth, go outside and get a tan and make its color darker? Did it, actually change colors itself? Or did the changes in our population occur because the best hidden moths survived and reproduced, passing on their colors to their offspring? So you need to choose, of those first two questions, which one do you think happened? Did the changes in the population happen because individual moths changed colors? Or did the change in the population happen because the moths that could camouflage survived and they could pass on their traits? This is making a connection to genetics. The traits that are passed from parents, how do those affect the offspring, or in this case, the baby moths? And then try to explain why you think that the individual moths change colors, or why you thought the best hidden moths survived and reproduce, and include that in your answer. Lastly, number 7, we've got the definition of the term biological evolution. That is the process by which populations of organisms change over time. So populations of organisms would be groups of living things in the same species. So in this gizmo, we were learning about the population of moths. How could natural selection lead to evolution? So how is the fact that moths that could camouflage became more common because they were not eaten, how could that lead to the population changing over time? We were only looking at this population for 5 years. And in 5 years, we saw on the light-colored trees that the dark-colored moths were all eaten up. And by the end of 5 years, you most likely had no dark-colored moths left. In the second part, you were looking at moths with a dark-colored tree bark environment. And so looking at that, we saw in 5 years that there probably were very, very few, if any, light-colored moths left in the dark trees environment. So even in 5 years, we saw that our moth population changed. So how does this show you evolution? It shows us evolution because as the moths that were not able to camouflage were eaten, then they would not be able to reproduce and pass on their color trait, whether it be light-colored moths or dark-colored moths. So over time, those moths that did not have the ability to camouflage with their environment would eventually die off because they would not be able to pass on their traits to offspring because they've been eaten. So do your best to try and answer that question using what I've just said. I'm sorry if I am rambling a little bit, but if you've got questions, please feel free to send me a Schoology message, and I will do my best to help you out. Have a great day.